hood. And as I mentioned a moment ago, we've got our product dissolved in methylene chloride, but there's going to be some water in there as well. So we want to get rid of that water, and we're going to go through a two-step process to do that. The first is we're just going to add some magnesium sulfate directly to this. Now, this is anhydrous magnesium sulfate. Chemists often get lazy and just call it mag sulfate. And we're just going to use the tip of a spatula and put this in here. And what we should find, now the magnesium sulfate was anhydrous, so it really wants water. Okay. And so we should see some in there that's kind of clumpy. And I do see that. So that means that we're probably pretty good here. We got it mostly dry. But I went and just added magnesium sulfate to it. Uh-oh, that's a problem. Why is that a problem? Because now I got a bunch of white solid that's mag sulfate. I want to know my yield. I want to know things like that. So what we're going to do is we're actually going to filter this through a column. So I've got a little bit of cotton, and we're going to take a little tiny bit of cotton. I mean, this is just like a little bit of cotton, not very much. And we're going to use for our column a little glass pipette. And in fact, the whole point of the cotton, it doesn't do any of the filtering. What it does is it prevents the magnesium sulfate that we're going to use from leaking out the bottom. So I've got my cotton and I've got a longer pipette, and I'm just going to use this to push it down and create a little plug at the bottom. I don't want it to be too tight. If it's too tight, then my material's never going to come through here. It takes a little while anyway. So now we're going to add more magnesium sulfate. Why are we so worried about getting this dry? Well, remember, water is an oxygen with 2 protons. Those protons are going to show up in the NMR. In fact, they would swamp our NMR. So we've got to get rid of the water to make sure that we can get a nice clean NMR. Okay. So I'm just going to pack what's called packing this with magnesium sulfate. I don't actually have to do it all the way up, but I do want it enough mag sulfate that it's going to dry things, but not so much that it clogs. That's a very fine line. All right, for what I'm doing, I'm going to say this is probably good. Okay. So I have my magnesium sulfate, a little bit of cotton there, and we're just going to clamp this. Make sure we put our lid back on. And then we're going to still decant to get as much of the liquid with as little solid as we can. Okay, so I'm going to go ahead and bring you in closer here so you can see it. Yay, up close chemistry. All right, so I got another pipette, and then I'm going to pour it in here. Now I need something to collect it. So I have a vial that I have pre-weighed. I actually wrote the weight right on the vial, so I didn't have to worry about losing which vial was which. And we're going to catch that in there. All right. So let's get some magnesium. Let's get our product here. You see a little cloudiness. Put it on here. You should be able to see it soaking through. All right, we got a little mag sulfate coming through. I could use a little more cotton in there, but it'll be okay. So something to think about is if some magnesium sulfate comes out, what kind of an error is that going to cause, if any? It's always good to analyze what your potential sources of error are. Now, if we didn't add some magnesium sulfate before we tried this column, we'd find is that this magnesium sulfate would get so clogged up with water that it would actually clump. And then the column gets clogged, and there's not really much you can do about it except build a new column. And that definitely lowers your yield because any liquid that's stuck up here you can't really get back. As much as I can without pulling over excess solid. If I hold over a little, it'll be okay. All right, so what's coming out here? Methylene chloride with our product. Hopefully, you can see it's going down, so it's going at a pretty good rate. When you're doing isolations, when you're cleaning up your product, this is a time where you often have to be very patient, waiting for things to go. It's real easy to get annoyed and want it to be done. and crank your temperature up too high, or try to squeeze on this, or something like that. And it almost always ends up taking longer because you usually have to start over again, or you just get really, really bad yields. Also not good. Okay, so we're most of the way down with our column. So then what we're going to do is we're going to take this pre-weighed vial that has our product and our solvent, and we're going to heat it very gently on this hot plate. I'm going to go ahead and start warming it up a little bit. Methylene chloride is a fairly low boiling solvent, as we've seen in the past. So we're going to try to drive it off. And as I was saying a moment ago, this is where we have to be patient. If we try to heat it up too quickly, then it will bump. And if it bumps, then that bubble that forms is probably going to launch right out of the vial. And if that happens, all our product goes all over the hood. That's not good. So we have to be patient here. I'm waiting for this to finish. Oh, patience is so hard. I feel like my second grader. I don't want to wait. All right, there we go. Now, we're going to gently heat and just very slowly evaporate off the solvent. In theory, we could just put it in the back of the fume hood and wait about 20-30 minutes, but we can speed it up a little bit with the hot plate and not go too far. So I'll come back when we have this done, because you probably don't want to sit here and just watch, well, it's not paint drying, but it's solvent drying, so it's pretty close. So we'll be back.